All right, guys, welcome back to Flat 6 Innovations. This is another Flat 6 Minute brought to you by RenVision and LN Engineering. So, yesterday I released a video that is kind of part one of what we're going to be talking about today in a more extensive video, which is kind of a post-mortem review of a 2012 997.1 GTS engine. Now, a lot of times people associate the 9-alpha-1 or MA1 engines without the problems of the predecessor, the M9X being the M96 and M97 engine. And by whole, I would think that that's obviously a good assumption. The engines that we see here, 9-alpha-1, at this point in the life of these engines, we don't have 31 modes of failure for this engine the way we did, 15 or so years into the M9X version of engines. So by and large, yes, I do agree that these engines were better. Are they perfect? No. Are there things that, as an engine developer, I don't like? Absolutely. The biggest thing I don't like is the fact that they removed the intermediate shaft. I believe the intermediate shaft was put in these engines for a reason, starting back with a 547 4-cam Carrera engine and going all the way through the end of the Metzger. So I believe that removing the intermediate shaft causes problems, and we've seen that because now we have higher surface speeds of timing chains, and we have seen timing chains fail that we had never seen fail before. Omission of the intermediate shaft also caused a few other things to occur because now you're not able to drive the oil pump with an intermediate shaft. The oil pump is now being driven with another small chain, and we've seen these chains break, okay? So with that being said, there are things that happen with these engines that I do not believe were the best of occurrences. But by and large, they have not been proven to fail at the higher rates of the M96 and M97. Now, keep in mind, there's not a lot of these cars out there, at least of the 997.2 era, because the economy still wasn't good. Not as many cars were being sold, and a lot of them were PDKs, which will not allow you to kind of beat on the car quite as much as a manual. And, at the end of the day, some of the things that were done by the accountants with the earlier engines didn't really go into these. We do still see bore scoring issues with these. Instead of being Locacil cylinders, these are Aluacil blocks. This engine does have some level of bore scoring. That's for another video. Today's video, I'm going to be going over with you the deeper, darker side of this that led to a catastrophic loss of this engine that honestly was not assumed. This catastrophic loss was something that was misdiagnosed, and I hinted on that in yesterday's video. So as we got further along with the disassembly of this engine, it was assumed to have bore scoring. That was a diagnosis made by two different shops. We were going by what we heard. The engine was delivered to us out of the vehicle. That's how most of these engines are delivered to us. We are not car guys. We are engine guys. We don't care about brakes and suspension or wiring or an ignition switch. This is the heart of the engine, and this is all we care about, which is what makes us the best in the world at our craft. We're not sitting here chasing problems with cars. We're not traveling to racetracks all over the country, burning gas and wasting tires. We are here in the lab. We're in the shop. We're in the machine shop. We're building, developing, and kicking ass. That's what we do. So with this engine, as we started taking it apart, we saw a few little copper flakes. And that turned me on to the fact that this engine was probably losing a main or a rod bearing or both, okay? So mains and rod bearings are at the heart of the engine. They're what supports the crankshaft and the connecting rods, okay? And when we start to see copper, a lot of times people that have less than enough experience with these engines start thinking, yeah, you got bad valve guides. The valve guides are wearing, and that's why you've got this. When we see copper, we know that a main bearing or a rod bearing or both are at the end of life, just like this. end of life, okay? When you see copper, you are already down into the final wear surface of this bearing. The only thing left is a steel backing. You've already gone through the aluminum, the tin, the lead, everything else that's in these bearings. You've already worn through all of that. It's trashed, it's done, okay? With that being said, as we move forward with it, we decided to, okay, let's document when we pull the oil sump plate off, because our customer needs to see exactly what we see, because he's been told this is bore scoring. And it's going to be very difficult to explain to him the reason why two different shops misdiagnosed this. And at the end of the day, they didn't know what they didn't know. If they would have just pulled the sump plate the way that I've always been instructing in my classes for the past 17 years, then this would have been an absolute correct diagnosis, and they would have said this engine is done with a capital D. Let's issue it a death certificate, and it's over with. Now, can we resurrect this? Yes, but we will only resurrect this engine if we know we have a 100% chance of success. In other cases, we'll replace the crankcase. But through extensive machining procedures we have at LN Engineering and also here in-house, there's a possibility that with our latest technology that we will be able to save this crankcase. We are only going to do it if we have a 100% chance of success. If not, we're going to choose not to do it, and the crankcase will be replaced. Replacing a crankcase for one of these engines is an expensive endeavor. I want to take you through what I believe to be the primary, secondary, and tertiary levels of failure with this particular engine, because this is not something that a lot of people get to see. These engines are assumed to be perfect. Everybody wants them to be perfect, but I'm about the here and now and about the facts. If they hurt your feelings, I'm sorry, grow some tougher skin. I'm showing you what can happen, and the fact that these engines are really no more immune to any mechanical failure than any other engine out there. Now, this engine came from a car that had a PDK gearbox. The PDK needed to be rebuilt. That work has already been done. So we know, since it came out of a PDK, it's not been over-revved, and to my knowledge, this car was bought by the purchaser who owns it now, and it's never been tracked. It's always been maintained, and it's never been abused. We can see that because it's fairly clean inside. At the end of the day, sometimes you just get a bad one. Other people, at the end of the day, get a really good one. I had somebody message me 2 or 3 days ago saying, hey, I've got one of these engines with 300,000 miles on it already. And I'm like, well, you know, I don't get that message from the guys that have M96s or M97s. But that guy also said, I went through 4 high-pressure fuel pumps. I went through 3 sets of injectors. I've had problems with timing chains that needed to be replaced. And they actually used our MasterLink timing chains for these engines to bail that system out, because nobody else makes a MasterLink timing chain that can be serviced in the car. But at the end of the day, this one has been clean. Now, you'll see the oil looks pretty dirty. That's because they had bore scoring. It's ended up with soot in the oil. So maybe the hypothetical situation would be this engine was ran with bore scoring for too long, and that bore scoring loaded the engine oil with soot, and that soot is akin to diamonds, okay? It's just like you're putting microscopic diamonds in the oil. And when that happens, now you have these microscopic diamond carbon particles that are diamond-like floating around in the oil, going to every single lubricated component in the engine. So as oil is being delivered through the oil pump and going through other things, some is getting caught in the filter, but not all of it. The oil pump in this engine is only protected by a screen, and that screen has got really big grooves in it, really big square weaves in it. So it will allow that debris to get sucked into the oil pump. The oil pump sees wear from that, and then a lot of it ends up getting pumped to your main bearings. So here, if you look at the oil system in these engines, oil comes through the center of the crankshaft first as a general rule. Yes, it's supposed to go across the entire crankcase, but it kind of comes in here more in the middle. So it makes sense if you have debris-laden oil that is not getting perfectly filtered because the factory filter sucks. And yes, it does suck. And if you don't agree with that, I'm sorry, but it sucks. And it has a situation where some of that debris gets through and it gets here to your main bearing, and the main bearing ends up in a scenario where it starts to generate debris, because as you induce foreign object debris, okay, soot, whatever, into the oil, gets there in high enough volumes, it starts to create wear on this main bearing. Now, keep in mind that for the rod bearing journals, okay, to see oil, that oil must first come through the main bearing. So oil comes through the crankcase, it feeds the main bearings, okay, and then it goes out to the rod bearings. So as this bearing started to wear, the debris that was generated from this failure was then centrifugally delivered via the oil supply and the rotation of the crankshaft from this main bearing directly to the rod journal. So the rod journal ended up wiping out its rod bearing. So at first, it had a noise. Everybody thinks it's bore scoring, okay? There is a trained ear that it takes to pick up bore scoring from a lifter noise, which really doesn't happen, or a rod knock. Now, we were never able to hear this engine run. It came to me on a pallet. And the shop that sent it here also never ran it. And at the end of the day, it's a good thing they didn't, because even more damage could have been done, because everybody assumed it was bore scoring and that bore scoring was just going to take out the bores. Now, let's look at the different levels of damage. So ultimately, something created the primary failure. And that primary failure, hypothetically and assumed at this point, is that the bore scoring created soot, the soot got into the oil, started taking out other things, and it probably put a lot of wear on this main bearing first. Total assumption, I'll figure it out later and tell you for sure if that's what it was. But based on my experience, this is what I see. So as this material was generated and a lot of copper was put into the oil, that was delivered via centrifugal force through the oiling system inside the crankshaft to this rod bearing. The rod bearing reciprocates. It's not just a dynamic surface. It's not just radial. The main bearings have no reciprocation. The main bearings are tougher and stronger and larger, and they don't see reciprocation, and they don't see load from combustion like you see with a rod bearing. So as the rod bearing gets more and more debris brought into it, it ends up taking out the connecting rod. And you can see this is smoked, okay? There was really no bearing left on this rod journal, because all the load from the combustion process was leading to a lot more load going on to this rod bearing that's been damaged by debris. Now, you can see here that this piston has been hitting the head. So as soon as we got this engine apart, I noticed, yes, this piston has been hitting the head, and this was not bore scoring. Bore scoring played into it, but the primary failure was that we had something happen in the bottom end. So the order of failure: primary issue, something got in the oil, we had an improper clearance on this main bearing, whatever the case may be, that led this bearing to shed material. As it shed material, it went into the oil supply within the crankshaft and was internally delivered to this rod bearing. It could not take the amount of debris and the amount of wear that it was seeing, along with high combustion pressures, and that bearing started to wear away. It started to make a knocking sound. The knocking sound was assumed to be bore scoring, because maybe it had already been diagnosed as having bore scoring before, which is what generated all the soot and nasty stuff in the oil and maybe even more metal. And that is what took out the rod bearing. So, primary failure, yet to be determined. Probably soot from bore scoring or something to that nature. Secondary failure, connecting rod bearing failure. Debris being released from this led to the tertiary damage of the rod journal that took out the rod bearing. Now, a lot of times people would look at this and they would say, well, the only thing that happened is a rod bearing. No, this was the symptom. This was not what caused it. This was the tertiary side of things. The snowball headed to hell was headed there long before anything happened to the rod bearing. So when somebody says, well, that engine spun a rod bearing, but did it? So people that have only been doing this work for a couple of years, that might be professionals, will probably look at this and say, yep, it lost a rod bearing, and they stop at looking at it from that point. They don't look further to find the smoking gun, because maybe there was an inadequacy with the running clearance on this bearing from the factory. And maybe that's what caused part of this. Maybe something was blocked in this oil system. Maybe there was a factory defect. In this world, we don't know what we don't know. So you have to search for every single thing that can possibly be a problem, and you assume nothing and quantify everything. So now this case goes through extensive procedures if we can save it. And this is basically what you see here, the main bearing that I pulled off of the crank shaft, okay, originally belonged in this half of the crankcase, all right? And it went here. Now, this surface is no longer proper. This surface is going to have to be machined and welded if we can save the case. Now, saving a case is something that's very detrimental to later in the life of the engine, because you can try to save things that should be thrown away. And I tell people all the time, when you buy an engine from a guy who's been in this business from the age of 13, when I started this business in a barn with a dirt floor, when I had my first paying customer for a Porsche engine, you're not buying your engine. You're buying the thousands of engines that we built before yours. And that's priceless. That's what people can't do in just a couple of years of experience, especially if their goal was to build an engine in 4 hours. At the end of the day, we look at things like this, and then we go into a sleuth mode. We have to find out exactly what caused this, and we can't put this engine back together until we do. So, can we save it? That's to be determined. There'll be some welding procedures. There'll be some oversizing procedures. There'll be a lot of things done in a $700,000 machine. And if anybody on the face of this earth can save it, it'll be us. But at the end of the day, we're only going to try to save it if we have a 100% guarantee in the back of our minds that everything we're going to do is going to work. If there's any reservation whatsoever, we're not even going to go there. This crankcase will be replaced. And that's the way the ball bounces when you assume nothing and quantify everything. Now, let's look at the other bearings. So one might say, this was oil starvation. This happens on the track. That's what happens. We will jump to conclusions. We must read the other bearings here, okay? And as we read these other bearings, we notice that there's really no wear. Not even up here on the nose bearing. Very, very, very little wear. That's the smallest bearing there. It's one that sees a lot of debris. We look at these other bearings. There's no bearing in this location, but we look at these others, and they look good. You know, a little bit of oil on it, but it looks good. And none of this stuff's been cleaned at this point, right? But the other bearings look fine. So something I've seen is that there are times where the factory would make a bearing diameter too big, or they would not cut the align bore properly, or both, and you end up with a bearing that's tight. If it doesn't have proper adequate clearance, it will fail. And sometimes tolerance stack up gets you, where maybe the case is a little bit too big, and maybe this is a little bit too small, whatever the case may be, and you end up with a snowball that was headed to hell from the time that it originally was built. This engine could have had this problem from number one get-go. It could have been destined to fail. And let's talk about that. Because what people that don't work with mechanical things all their lives, and especially today, what they don't understand is this engine begins to die the day that it started the first time. Just like a human, we start to die the day we're born. Every engine will wear out if it doesn't fail first. I don't care what the engine is for. As someone who has lived with mechanical things my entire life, and everything in my world has been mechanical, from helicopters to airplanes to Porsche engines, air-cooled and water-cooled, to go-karts to jets, Every engine I've ever worked on will die. None of us are perfect. The perfect engine does not exist, period. It will never be perfected, and that is why we are practicing engine building and engine development every day. It's nothing that's ever perfected. We never know it all, but we know a lot more than somebody that started 2 years ago. Talking about bore scoring, you can see here, this cylinder definitely had bore scoring, right? And it started to lose the skirt dimension. You look at this very closely, and you'll see that this cylinder had bore scoring going on because it ended up on the piston. This is the same one that lost the rod bearing. Well, the ankle bone is connected to the neck bone, so all of these things play into everything. So with any failure, there is never one single factor. When people ask me what made that engine fail, you know what my answer is? Everything. Because that's what the last 35 years of my life and experience have told me. It's everything. When you have a failure, there's no single smoking gun. There are usually things that play into it. Now, I will say in a case where you break a rod bolt, a factory rod bolt, that can be a single failure because that bolt finally said, I'm giving up. When it gives up, the rod cap snaps off, all hell breaks loose, things go through the engine, pistons become disconnected. You're probably at Sebring or Road Atlanta or Barber Motorsports Park, and you end up with something blown up on the side of the track. And you call me on Monday morning and you say, my mechanic, who's not an engine builder, says that my piston became disconnected from my crankshaft. Well, that's why. But that's usually the only time where I think you would truly have a single failure that leads to something. The rest of them are a stack up of things that lead to a problem. It's like a Swiss cheese model. We learn in aviation where when you have too many of the holes in Swiss cheese align, you end up with a big problem. And when those things don't align, the problem doesn't happen. It's just like lining up the holes in a piece of Swiss cheese. So a piece of the rod bearing actually fell out here while I was talking to you guys. That was still welded on the inside of this connecting rod. So now that we've talked about the problem, let's talk about the solution. And I've yet to go over this with my customer. I'm actually going to share this video with him and let him see what we see with everything not being cleaned up and it being just real. Now, I'm going to end up using my Omega Sonics ultrasonic cleaner to get all this stuff cleaned up enough that we can look at it and we can try to find a little bit more out about the story. We're not getting paid for doing this level of work. We thought this engine had bore scoring, so this is all kind of freebie stuff where we get stuck having to make sure that there's nothing going to bite us in the ass later. We have to find every problem with this engine right now. And the clock and the calendar don't matter. We have to find exactly what the problem is. Otherwise, the problem can come back and bite us when my name is on this engine. This is the reason why there's no compromise, and it's the reason why we only do things the right way. Now let's talk about what we're going to do with this. So we have the capability to repair the crankshaft. Probably not going to do it because it's probably cracked. We're not going to trust it. I've got a big cache of these crankshafts, so we'll probably end up replacing it. I've actually got one that came out of an engine that we pulled apart that only had 10 miles on it because the guy just wanted it to be the biggest, baddest, fastest thing there were. And back in 2009, we took that engine apart and made it into a 4.2 liter, and we did not need his crankshaft. So if I've got a crank that measures up with what this engine needs, I've probably got that covered. The original plan was to build this engine to a stage 2 4.0 liter. So we will probably still move forward with that. If that crankshaft I've got as a direct replacement for this will not work, then we will use one of our billet cranks that's got increased stroke, and we'll take it to 4.2 liters, okay? This vehicle was sent here, like all others, with an open checkbook. That is the only way in which we take on an endeavor like this. It costs what it costs, and it takes what it takes. We make estimates at the end of a project, and everybody knows that going into it when you're doing something like that here, and something being done here at my Skunk Works facility where we only do the crazy stuff that has no budget. And that's pretty much all we do these days. That's what people want at our level. So if we can save the crankcase and if we can save the crankshaft, that's going to make things a lot easier. We'll move forward with a tentative plan of making it into a 4-liter. We'll end up doing cylinder head port work to it. We're going to change the valve sizes. We're going to use our valve springs. We're going to increase compression ratio. We're going to increase bore size. We're going to Nickel plate these cylinders. And we're going to build this into the same thing we've been building these engines into since the time they were new, when we completed our first one back in February of 2010, when we took an engine from 3.4 liters to 4.2 liters and added 100 horsepower to it. The first ever performance MA1 engine happened here at Flat Six Innovations. Now, in the first one, we didn't get it right. We blew up 3 transmissions in the first year, and we learned. But that's why we do what we do when we do it, at being at the forefront, being the pioneers, being the guys that are getting paid to blow things up. That's how we learn. That's what we do. So, I don't care if the rods are bad, ultimately, because the rods and pistons are going to get thrown away. Here, there's no compromise. I'm not going to look at this and say, oh, I think we could save that, or that rod's okay. This thing goes in the junk pile. I took 3 55-gallon drums full of perfectly good parts like these to the scrapyard last week. I know this was built by the lowest bidder, therefore I'm not going to use it. We're going to use a made in USA billet connecting rod in this position. And, we're going to get rid of a weakness, because obviously we could have ended up having broken rod bolts here, like what happens in most cases, but these rod bolts were just starting to work loose. They had lost their torque. They were starting to fail. They were starting to stretch. But we don't care about these because I think they're junk and they're getting thrown away. Most of the fasteners are going to be replaced with items that we make ourselves. The camshafts will be getting replaced with camshafts that we grind ourselves. The timing chains are going to be replaced with timing chains that we've had made that have master links in them so they can be serviced later. The oil pump will end up being rebuilt and modified if it did not get taken out by debris. If it did, then I'll start over from another one and go from there. Cylinder heads will see a full port and polish. And people say, well, these heads are good already and they don't need that. Well, maybe for your engine that doesn't make the power that ours does, that doesn't eat gearboxes like ours does, then maybe that's the case. But please keep your opinions for what matters with your engine, and don't use those opinions on my engine, because I will guarantee you they do not pertain. If I did not need to do cylinder head work for these engines, I wouldn't do it. But we've learned that we must do that to have a fully good combination that is coefficient in design and that everything matters with. I'm not just going for what I see on a peak horsepower number on a dyno. I've had a dyno every day of my life since the age of 23, and Mr. Harvey Stuska himself told me the things that his dyno was good for and the things it wasn't good for. And I've always remembered that. So at the end of the day, we're not racing dynos. I've got 3 of them, 2 engine dynos and a chassis dyno. If anything, I think the chassis dyno is the winner of all 3. That's the reason why I use it more than the other 2, which are pretty much set aside for doing air-cooled testing or water-cooled engine development, where I might have an engine on that dyno for a year. Okay, so we're going to increase this engine to about 4 liters. Usually this makes about 80 extra horsepower, but that's always up to what the person wants to do, what we do for exhaust, if somebody's using our headers, our X-pipe, our intake, or if they want to keep things with generic parts that are not designed for the larger engine. So just wanted to take you guys through this failure and help you understand kind of what it takes to do this type of work, and be a sleuth. Because ultimately, not everything is the same when it comes to a failure. Like a car comes in, we think it's got bore scoring, we start seeing some copper, we're like, misdiagnosis. Let's go into a different mode. Let's get it apart. Now let's clean it up and figure out what happened, and then let's see if we think we can save it. All right, guys, so this has been a flat 6 minute here on a Tech Tuesday. Been a pretty long video, longer than what I planned. I hope you guys learned something about it. To many of you, this will be a shock. Oh my goodness, a 9 Alpha 1 engine has failed. We did not think this happened. We see this a lot, but at the end of the day, it's because we are the best in the world at this and everyone knows it, and therefore we get these engines that would normally either be thrown in the junkyard and replaced by a factory engine that can fail in the same way, or somebody chooses another builder who's only been doing this for a couple of years, and they end up with a bit of a buffet that doesn't taste very well. Okay, guys, Jake Raby, Flat 6 Innovations, here for LN Engineering and RenVision. Hope you learned something. We're going to get this all taken apart, find the smoking gun. I'll post version 3 of this video, or volume 3 of this video, in a few days once we've learned a little bit more. Raby out.